Thank you all for joining. Welcome to InRhythm Lightning Talks. I'm your host, Parag Katkar. I'm the head of consulting practices at InRhythm, and we have lots of exciting lightning talks lined up for you in the upcoming weeks. Our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time. And each week, one of our practice area consultants shares their knowledge in the latest technology trends in the industry. So today, Sid Akula, who is a senior software engineer with us, is going to give us an overview of GraphQL with Java. As a lot of you know, GraphQL is a query language for APIs, which gives the clients the capability or power to ask exactly what they need, and it makes it easier to evolve APIs over time. I'm curious to hear about the best practices of using GraphQL with Java. So without further ado, let's get it started, Sid.
Yep. Thanks, Parag. Hello, all. Good evening. I'm going to get started with the GraphQL. Parag gave the brief about what is GraphQL. I'm going to go a bit deeper into what is GraphQL and how we can use in the backend apps. So first of all, to know what is GraphQL, GraphQL is a query language that is used in the server-side applications as well as front-end applications to reduce downtime, increase the efficiency, and speed up the applications and increase the flexibility of data fetching and their effectiveness. There are a few things we'll be discussing today, like what is GraphQL and the differences between the REST and GraphQL in the Java apps, and when to choose GraphQL or REST. Also, I'm going to go about what are the best practices of GraphQL and some of the drawbacks of GraphQL. And let's just see how is the response object looks like when a GraphQL request is fired. And we'll do some hands-on. I'll just show basic querying practices. And then what is querying, what are mutations. Those are some of the important topics we need to know about the GraphQL when implementing into our enterprise applications. So to start with, GraphQL is a query and manipulation language for the APIs created by Facebook in 2015. There are so many applications of GraphQL, and a lot of enterprise applications are being implemented on top of by using the GraphQL because it's an open source language and it supports most of the language to integrate with, and it provides the concept of event-driven applications as well as the subscriptions. It is capable of retrieving the data which a user has requested against how the REST uses the data fetching policies. And unlike its older analogs, GraphQL offers smarter approach to working with data in a faster way with all the substitutes it has. GraphQL depends on the data and code that's behind it, since it's linked to the storage as well as the backend applications directly. If you have an enterprise application and when it is easy to fetch the data, we don't have to build the whole policy of REST applications how we do, and we can just simply integrate with GraphQL to fetch the data. To simply put, the reason GraphQL came into being over the REST is shown in this image. Most of the times when a GraphQL, when an application is requested for when an API is requested for some data, the whole bunch of data is sent back to the client or the UI. Whereas in GraphQL, we just send what is necessary. So if a front-end developer is requesting for something like just a username, then most of the times we end up sending the whole object of the user instead of one field, whereas that can be avoided in the GraphQL applications. So some of the major drawbacks of REST, which gave to the GraphQL, is that only one can download predefined bundles of information in the REST. If you want some information of a bundle, you still have to download all the application and the parts of it. So every bundle, if there are 1,000 bundles, still we have to download everything for a single field to be used. Whereas in the GraphQL, everything is predefined. Client can send the changing data needs for all these bundles based on parameters and variables and everything that can be defined with control by the client. When there is a need for API layer, and when we don't want to have a lot of service logic and business logic, we don't have to go through a standard MVC application style, and we can just integrate with GraphQL, and we can simply fetch the data from the databases with a single layer instead of having multi-tier layers. Subscriptions and event-driven apps are something which rely primarily on the events being fired and subscription notations being requested. In those applications, still, again, by using REST, we have to go through the policies of multiple layers of controller, service logic, and DAO, etc. Whereas by using GraphQL, everything can be integrated directly to event-driven actions or the functions and subscription notations, because GraphQL has control over predefined functions and how they can be changed over runtime. If you see here, the differences between GraphQL and REST can be seen in few points. A single HTTP endpoint can be controlled in the GraphQL. Everything is driven by the client, whereas multiple HTTP endpoints needs to be shown in a REST protocol. One network call per query, where to derive multiple events of data, we need one network call per query in the GraphQL. So it's same as a REST application. It's a bit different in terms of the endpoint that we access. And client-defined response content, like I said earlier, it's same. Whereas entity server-driven response is happening in the REST endpoints. Strictly type schema, and it requires real-time data support, whereas schema is optional in the REST. And for more complex code, it supports more in the GraphQL. The initial setup is a bit complex. It has more complex code to start with, unlike the REST, where we have a simple REST layer by using few dependencies. Some of the drawbacks in GraphQL is app is generally coupled when the client-side coding is being done, and the state of application is not controlled by the server. Unlike REST, GraphQL has no caching mechanism on the client, which can be controlled from the browser, whereas GraphQL doesn't support the same. I'm just showing a simple structure of GraphQL requests that can be passed from the browser or a client. We are getting away with all the quotes and all the strings and all the commas in the GraphQL. A simple structure like we see here works for the GraphQL. So this is the response object. I'm just comparing with the REST API object, which has standard notations of inverted quotes and commas and everything. It is simplified because most of the times when you have complex input objects, we tend to get confused, and there are times when when we have 1,000 line of request body, we tend to miss a comma and pass over the request, whereas all these small notations are not considered in the GraphQL request. Let's get hands-on with the GraphQL coding part. This is a simple GraphQL applications which can be used for us for a bit of demonstration. We have annotations like query mapping, mutation mapping, and schema mapping. There are many other applications of GraphQL, but I just want to get started with a simple applications of GraphQL. I started the application. Okay, the app is up. Here I'm sending a request to fetch the data like ID. This is a simple structure, like I said before, this is a simple structure of GraphQL querying. There are other functionalities like mutations and schema mapping. Querying is equivalent to get API in the REST APIs. But here we'll be using standard same URL for all the APIs, like you see in the other URLs. It's just the host /GraphQL, and it's a post call. but the only difference is the input is having different types of request bodies, where one is query, other one is mutation, and schema mapping is similar to mutation. I need to update. For a query structure, the book details is nothing but an object that we are requesting. If we look at the code, for fetching a query mapping, I'm having a book by ID, which is same as what we are defining in the request body. We have query, the book details object, and book by ID is a function name, and ID is what we pass in the request. Just like a request param in the get APIs, we send the ID and we fetch the respective data for this ID respective book data. When I said all the data is controlled by the user, I can remove any number of values. Earlier, I fetched ID, name, page count, and author. It is a wrapper object which is having 2 fields. And when I send another request with just 3 fields, it gives me respective data for only those 3 fields. This comes into picture. So there are numerous enterprise applications, for example, banking applications, insurance companies, and data analytics for the healthcare. All these applications have user details along with tons of rules and configurations. All this data is generally passed as a response body when a request is passed with single identifier. So all these big enterprises which place on tons of data started migrating into the GraphQL just because of this simple flexibility. When we are not fetching 1,000 lines for one single field, we are obviously saving a lot of data and time, and response is faster. Mutation is similar to a put API. It is next. Mutation is similar to put API. Most of the APIs does support post calls, does have similarities with the mutation API. Next to requesting information from a server, the majority of application also needs some way of making changes to the data, which is nothing but the put or post or any kind of update operations that we do in the REST APIs. This is similar to mutation. We can pass an object with some data to update an object, or to create a new object, or to do some kind of changes to any kind of backend data to delete as well. Mutation works to delete the data as well. All these functions are applicable in the mutations. Whereas schema mapping, schema mapping is used to parse multiple objects. Schema mapping is similar to the mutation. The only difference is in the schema mapping, we are creating new objects and defining types in the schema mapping as a separate request. Just want to show a small diagram. The initial integration might be difficult. It might look like, for a simple application and a small demo, it might look like easy. But the only complexity for GraphQL applications is when we are using enterprise applications that have event-driven use cases or subscription use cases. It becomes the complexity of the application becomes huge in terms of integrating with GraphQL. That's the reason I put in here, as when we jump into the code, that's when the real problem comes in for the complex cases. As I discussed, querying is nothing but retrieving of data where we can specify fields and can pass in variables to fetch the respective data. Mutations are for CRUD operations, primarily to alter data and specify properties to be returned, and passing variables or to delete objects or to update objects. Some of the other functions are, as I discussed, the schema mappings and subscriptions which are available. Subscriptions are primarily being used nowadays on paginations and applications where there used to be RSS feeds in the functions for many newsletter applications or news applications. The GraphQL is extensively being used where the pagination is being used. In conclusion, GraphQL brought in a paradigm shift in how we access APIs, and Spring Boot is offering its own libraries for the GraphQL as the popularity of the GraphQL has increased. So it makes it easier to upgrade our since the data is faster to access and flexible to access. Any questions?
It's a great talk.
Hey, Ted.
Sid, I have one question at the last if you have time. I mean, how much time does it take to build a MVP with the CRUD operations with GraphQL on the backend side?
Can I be more specific? How much time does it take means to integrate with GraphQL or?
Yeah, so I mean, let's say if we have you're building a new application with Spring Boot and GraphQL, how much time does it take to build a basic MVP kind of application like with?
So everything is just like REST. Everything is offered for GraphQL and Spring Boot applications or Java applications. The libraries are inbuilt and everything is readily available. It's just matter of flipping the annotations and changing the objects.
Okay.
So I would take, depending on application, if it is a small, less than an hour, and if it is a big, depending on the amount of load we are putting in.
Yes, thanks.
Gary, you have a question?
Yep. Hello. Thank you for your presentation. Great presentation. Just a question. From your experience, what are the use cases for using GraphQL or REST? How can we juggle which one to use?
Definitely. So I would say when the UI and backend are working in independent silos, it's better to go with the GraphQL because you can never override, like GraphQL has the flexibility of using amount of data that we want to pass and amount of data that is consumed by UI. In those cases, GraphQL comes into picture where we have fixed set of contracts between UI and backend. It's okay to continue with REST unless we want to improve the efficiency and flexibility of data operations. So if in my analysis, when we are directly integrating without any middle layer or other bridges, it's better to go with the GraphQL.
I can add some more detail to that. So it was like, I think few years ago, I was at American Express. I was consulting over there, and we had implemented GraphQL. And the advantage that we got was you compare different cards and all. So, for example, we had a lot of components which had varying degree of information in it based on where you see it. Like if you see it as in a compare mode, you'll have less information. If you go to the card detail page, you'll have more information. So then we, based on where we are calling that API from, we were able to get exactly the data that's needed, and that helped a little bit in performance. It was not a huge performance boost, but that was the intention behind using GraphQL, switching from the REST to GraphQL.
Yeah, one more use case that I've used in my own application is I was building a UI app, and there are multiple functionalities in the UI like drop downs, radio buttons, and stuff like that. And when we don't want the drop down to show us initially, the initial fetch is easy, and the drop down functionality is already built in and it's integrated with the backend. So whenever we click on the drop down functionality, we don't make a new call. It is event based. So based on the event that the dropdown has invoked, the data is already automatically fetched. So in cases like this, like GraphQL comes into picture where we don't have to make a new REST call.
From this perspective, I can say that every time we can have different consumers of our API, and maybe always it's better to use GraphQL than REST.
Yeah, I
But
think
I don't believe that, that we can make this kind of a statement. Always use GraphQL instead of REST. Yeah.
Can't. Yeah, I mean, REST is pretty powerful. So REST works for anything. It's been there for like so many years. Yeah.
Yeah, it's more mature than the GraphQL.
Yeah. Thank you.
Ted?
Yeah, so I was just kind of curious, like, so when you were learning about GraphQL or you're first getting started with it, what, like what was the most like surprising thing you learned about it or getting involved with it?
We don't need the most exciting thing I learned is we don't need 1,000 endpoints in GraphQL applications. It's just changing the request body. We don't have to keep track of all the URLs. A 1,000-liner Swagger document is something we don't need in the GraphQL. That I loved about it in the GraphQL.
Yeah, great, thank you. And then, so I guess along the same lines, I was going to ask you, so what do you like most about GraphQL, and what do you like least about it?
Yeah, it's a bit vague question for me, because what I don't like about GraphQL is we can't migrate all the applications that are already built in REST to GraphQL that easily, because there is a lot of specifications change. Like I said, the thing I like about GraphQL is simplification of URLs. Yeah, we don't have to have a separate URL for address, for user, for PCI data, or for PII data. Everything can be put in though it may not be easy, everything can be put in a single object with a lot of wrapper objects and can be based on use case.
Okay, great,
Yeah,
thank you.
Another question. Maybe it's better to build this GraphQL on gateway level, and just still we have our REST APIs, and on gateway level it will leverages which fields to return or not to return to end user. So we will have some kind of multi-level architecture. Still we are implementing our REST endpoints, and for this kind of different endpoints with different inputs and outputs, we can leverage with some kind of gateway level or one level above than our REST endpoints.
Definitely. For some applications, when we have microservice architecture and some of the microservices are not having complex data algorithms, like for example, if there are 10 microservices and 5 of the applications just have to fetch the data from database. In those cases, we don't need multiple layers to fetch the data from the controller to database, because all the objects are predefined, and schema is strongly typed in the GraphQL. We don't have to play around changing of objects. It is easy to manage between the database and the GraphQL since everything is typed in the format. That can be used as a gateway use case. Yeah, Gregory.
Hey there. I was wondering if you were ever concerned that maybe the front end knows too much about the back end structure with the query language. Have you ever had a concern just that since you are having to send a query, is there ever been a concern that it's just the front end knows too much?
Not really. Front end knows too much only if it wants to know, to put it simply. When it don't want to know it, well, we are not revealing all the information upfront. Did I answer that question?
I guess I was wondering more from a perspective of if somebody was doing network traffic sniffing or trying to just attack your endpoints, your GraphQL endpoints, would this represent any security risk on somebody being able to dump your entire database?
Well, that's a very good question. I haven't explored the security standpoint. In control of data, I think that's the next step I should be exploring.
Okay, thank you.
Yeah. So, Greg, that's a great question. I would think that would also depend on how you've designed it, right? So you could have that almost with anything, but if you like, because you could be returning data, and maybe ideally you would be in names that are not necessarily the same that your database uses, right?
In the complex conditions of confidential data being accessed, I think they're all identifier based. So right now, the REST APIs, we can't take GraphQL for inter-microservice communication or inter-application communication. So those cases are still used based on the authorization and authentication. But in the GraphQL, a simple use case of data fetching is straightforward. I think for inter-microservice communications, it's still complex as it is.
Correct. Like you mentioned earlier, you said get a query by a given ID or a single attribute would be a best use case or a fit for fit when the GraphQL can be used. Where the internal structure of the application is underbuilt, and also if you don't have multiple parameters in the request, then the whole request object is not compromised. Basically, whatever you get back in the response is already known. I mean, if it's a public API or a protected API, if an authorized user is accessing the endpoint or the system, then they will definitely get to know what are all the response attributes. So, I mean, you said that there is no concept of REST. There is no concept of endpoints as such, right? In the backend.
Yeah.
So when you make let's say, I mean, you're selecting a dropdown, and it is going to make a query instantly to the backend, right? So is there a way to I mean, every time I click on the dropdown, it is going to make a call. Is there a way to block that operation? I mean, can you configure it? Because every time you keep calling, you keep selecting the dropdown, then it keeps making like numerous
The
calls to
additional
the backend.
network call then, yeah.
Yeah, Nikhil, it's not a protocol-based network call, I would say, in the GraphQL. The internal functioning is like event-driven when it's based on the single event that is like invoked in the front end. It's not like making a REST API call or a network call, which needs to perform a round trip of operation for fetching the data.
Okay. Yeah. And one more question along the same lines. If how are the contracts managed? I mean, how is versioning of these implementations or services carried out? I mean,
Sorry,
like,
Nikhil.
yeah, let me reiterate the question. I mean, the API functionality is generally enhanced or upgraded, right? So based on that, we have different versioning of the services. How does it manage? Because it is strongly typed, and if you're going to change something on the backend, then it is definitely going to affect the current consumers of the API, right?
The contracts.
Correct. So is there a way to have backwards compatibility implemented or some kind of versioning implemented?
So in a case, the reason like GraphQL came into picture is one of the application is to avoid the the change of contracts. UI and like I said, UI and backend are working in their silos, and the changes in the backend are not always communicated to the front end. In cases like that, like they send what they need, they ask request for what they need, and we send what they want. So in a case, if there are like additional fields, it's just not used in the front end, unlike the REST API.
Okay, understood. Thanks, Sid.
Yep. Awesome questions. Love the discussion.
Yeah, good discussion. Any other questions, guys? All right, let's wrap it up then. First of all, awesome talk, Sid, and great questions, good discussion. We do these lightning talks every Thursday, 5:15 p.m. Eastern time. You know that. Next week, Andrew Balmer, who is a lead iOS engineer with us, is going to give a talk on machine learning. Super excited about that. Make sure you mark your calendar for next week. Thank you all once again for joining. Have a wonderful evening, and I'll see you guys next week.